Hi, welcome to another video on my Arduino Mega2560 and test with pulse width modulation on some electronics, including fischertechnik pulse width modulation motors. Last time I changed the code so that pulse width modulation in the frequencies of which should be between 40 and 120 Hz, but are set to 120 Hz only, are going through all ports. However, the frequencies I measured were not exactly as expected. So what I want to do now is find out why they are not as expected. And let me see. Therefore I do use this multimeter, which is set to measure frequencies up to 20 kHz. And when I measure from the mass up to here, it is 4 kHz. So what happens if I put another resistor right here? And I should not touch the camera so much. And what if I measure here again? Then I get 120 Hz exactly. I hope you can see everything nicely. So the point is that here I don't measure 120 Hz and here I do. What is the difference? This one is going from port 4, pin 4, and the other one, yellow wire, red wire, port 3. And when I look into the code, they are all set to 120 Hz. And these resistors are the same. So let me measure once again. This one shows, well, 2.5K almost, and this one is clearly set to 120 Hz. What does the other one indicate? Not even close. And this one is the green one and is port 4. So the middle one is correct so far. What I'm going to do is add another resistor to both this one and this one and see whatever happens. There is space to put them there, so let's do it. So here I have another resistor of the same value. However, I have to put it in series somewhere, and since there is space here as well, I can just as well move this white jump wire. So I turn it around. That is one, which should be, yes. This one is going to be here. And then this jump wire is moved from this location to here. Alright, so now it is about the resistance of 340 ohms. But what is the frequency? 15 kilohertz. That is ridiculous. But also this light doesn't respond to the switch. So okay, let's remove it again. And let's move this one back to where it was. And mind the wire, not to bend too much. Okay, so that is a clear sign that I should leave the resistors as it should be. What is the voltage over them? Let's first measure also. No, I quit the ohms because that was clear. And now I need to find out the voltage over them, over it. The wiring is quite weak. I measure the voltage, it says minus, and that is a little bit weird. Measuring here, 100. That is quite odd. So I can't explain exactly why this is like that. Let me measure the voltage over the third LED. Also very, very low. So that makes me think that I'm doing something wrong. Question is what? So, reviewing the code for the pulse width modulation. I changed all this last time, and just let me, oops, I shouldn't do that. Insert, and then it is about the timer 0, timer 3 and timer 4. Timer 0 is for the pins 4 and 13, timer 3 is for the pins 2, 3 and 5, and timer 4 is for the pins 6, 7 and 8. The pins that I do have in use are 2, 3, 4, 5, 6, 7, 8 and 12. And 12 being actually the pin for input of that switch to the chain motor. So I don't need to do that in here. Prescaler is 4, which is for the 120 Hz, as you can see. Then the prescalers are odd with timer 0, 3 and 4. And yes, that should give 120 Hz. So what I need to do now is to have a look at pin modes, how they are doing here. Is this correct? And are these correct? Analog output pin 2, 3 and 4. And these are pin modes 7, 8, 9, 5, 7, 9 and 11. This is for digital input. What if I change all that? Although I doubt that it is that much of a problem. But I can check it, like, yeah, 4 and 13, 2, 3, 5. This is 2 and 3 anyway. What happens if I comment them out anyway? There's 2 and 3. 5 is already out, and 5 because the middle LED is connected to which one? 3, which is exactly the one that does its the 120 Hertz. So commenting these out is not going to help. How about the other two? It is about 1 and 3 being output 7. I can output this, the other one being connected to 5, which is this one. So if I do this, what will happen then? let's just see. I'm very curious about this result. Compiling. No errors in compiling, so that's a good one. And back to camera to see whatever the results are of this one. Who knows, there was an interference. So, change the code, no errors, time to measure. And I do have to change my multimeter to the frequencies. This is the mass, and I have to check. Oops. This is in no way good. 14 kilohertz. How about pin 5 coming from well, let's measure here. Still 15 kilohertz. Let's measure here. 15 kilohertz. Let's measure here. Well, that's of course well, slightly less. This is slightly less as well. Let's measure here again, and this is saying 120 Hertz. So much for my theory. Are they really the same? Resistors? Actually, they look like it. What more can it be? I did 5 and I did 7. Let me... Yes, pin mode 5 and pin mode 7. 5 goes here and 7 goes here. So it's not that I can say it's logical. Nine isn't used right now, so it's a complete mystery why this works like it does. I can also check here. Pin 4 goes here. No, this is 3. This one is completely separate, coming from 8. And with 2 wires going to the motor, but that's not the topic of today. I can try to reseat anything, just seeing that everything is indeed set correctly. And the way I see it, I can only confirm however, I see that the lights are no longer blinking. So there is a difference. This LED only blinks when you press on it, oddly enough. So why does it stop moving now? And there it goes. For now I'm a bit clueless. Let's find out further. Reasoning again about the wrong frequencies. As I mentioned earlier, there are pins 5 and 7 that give the wrong frequency, and what I see here is exactly the other way. That 3 is enabled and 5 and 7 are disabled. So what if I enable them again? And probably this has no influence. So let us just see what that means. For the rest, it's analog write 3, but that should have no real influence on this, because there's no only 5 is here, but 7 is not here, so I doubt that that is something serious. Alright, let's see how this ends up. Very quick compile and upload. Having a measurement on first is 7. And it has no consequence whatsoever. Let me check the other one on the third LED. Also no consequence. It is still 14 and the middle one at 3, pin 3 is still correct. So this is not a solution. And it is about 5 and 7, so let's see further what is about 5 and 7. Not here anymore. Not here either. Although 3 is here written. So what about 5? Let's say I enable 5. It is of course connected, and let's see what this brings. Alright, let me measure on 5, which is the third LED, and lo and behold, that goes flashing like whatever. And it is extremely low value. So that is a nice result. Then I should copy, enable this one and have it go to 7. Upload as well. Yes. and that one goes too. Time to show you, because this is apparently directly dependent on this analog write action. So as you can see now, and let me dim the light a bit, you can clearly see that these LEDs are now blinking quite fast. So with that result, let me measure everything now. This one is still not 120 as I set it up in the software, but it's quite close now. This one is also coming much closer. So let's go find in the software why. Because I think it is not just about software, it is also about the value that it displays. 5 and 7 are writing output values 1 and 3, which I defined in the software as 1 and 2 voltages. But I do see that these two are quite fast blinking, while this one is hardly blinking and this one displays really 120 Hertz. And these two, as you could see, are not 120 Hertz. So the question is, if I change the value, is that going to change? So let me do that for a moment. Oops. Stay away from the camera. I change them both to output value 1. Upload. Alright. I hope you can see how fast they go. Now I want to have this one go as well, which is connected to, as said before, port 4. Is that true? No, port 3. However, port 3 is also having output value 1, so it should be blinking, but it doesn't. So it is not completely clear what is happening, but this is at least a change, a nice change at that. So as ending of this episode, let me measure again. This is varying a lot, but it is around 300 Hertz, 240. This one is clearly 130, 130, and this one is also varying a lot, but let's say around 300. Nice results, coming closer, not there yet. So for now, thank you for watching, and to be continued. If you're not subscribed yet to my videos, please do so. If you like my videos, may consider to allow ads, and or look at my website, how you can support my website and videos. So, thank you, and to be continued.